the genesis and the design paradox. The universe began approximately 13.8 billion years ago from a singularity, a point of infinite density and heat, smaller than a single atom. This Big Bang was not an explosion in space, but rather the rapid expansion of space itself. From this microscopic beginning, the vast cosmos we observe today emerged, governed by a set of mathematical laws so precise they border on the miraculous. This leads us to one of the most profound questions in science. Is the universe a product of blind, chaotic chance, or is it a carefully crafted story designed to be understood by conscious minds? Chapter 1: The Precision of Physical Laws. To understand the design paradox, we must look at the fundamental constants of nature. For example, if the strength of gravity or the electromagnetic force differed by even a fraction of a percentage, stars would never have formed and atoms would fly apart. Sir Fred Hoyle, a famous astronomer, once remarked that a common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics to make life possible. Chapter 2: The Role of Mathematics. Theoretical physicist Eugene Wigner famously spoke of the unreasonable effectiveness of mathematics. He argued that it is a profound mystery why the human mind can use abstract numbers to predict the movement of distant galaxies or the behavior of subatomic particles. This suggests a deep underlying harmony between our consciousness and the structure of the cosmos. Chapter 3: A Universe Made for Observation. The paradox lies in our own existence. We are composed of stardust, elements forged in the hearts of dying stars billions of years ago. As astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." Are we merely a biological accident on a pale blue dot? Or is the universe fine-tuned so that intelligence could eventually arise to witness its grandeur? As we peel back the layers of space and time, we find ourselves caught between the cold randomness of physics and the undeniable elegance of a universe that seems to be waiting for us to read its story. Part 2: The Absolute Precision of Physical Constants. Imagine a cosmic control panel with dozens of dials, each representing a fundamental constant of physics. If you were to nudge any one of these dials by the width of a hair, the entire universe as we know it would vanish into a chaotic void. This is the mystery of the mathematical key, the reality that our existence hangs on a thread of impossible precision. Chapter 1: The Knife Edge of Gravity and Expansion. A primary example is the cosmological constant, which describes the energy density of empty space. If this value were larger by just 1 part in 10 to the 120th, the universe would have expanded so rapidly after the Big Bang that matter could never have clumped together to form galaxies. Conversely, if it were slightly smaller, the universe would have collapsed back in on itself almost instantly. The late physicist Stephen Hawking noted in A Brief History of Time that if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. Chapter 2: The Nuclear Force, the Breath of Stars. The precision extends into the very heart of matter. Consider the strong nuclear force which holds atoms together. If this force were 2% weaker, hydrogen would be the only element in the universe. Stars could not fuse atoms, and water, and thus life, could not exist. If it were 2% stronger, all the hydrogen would have been consumed so quickly in the early universe that no long-lived stars like our Sun would remain today. Chapter 3. The Goldilocks Enigma. This phenomenon is often referred to by scientists as fine-tuning. Astronomer Sir Martin Rees identifies 6 specific numbers, fundamental constants, that govern the universe. He argues that the precise tuning of these numbers is what allows for cosmic complexity. This leads to a staggering realization. The probability of the universe possessing the exact values required for life by sheer accident is akin to an archer hitting a 1-inch target on the other side of the observable universe. This mathematical coincidence provides a powerful foundation for the intelligent design hypothesis, the idea that the universe was not a roll of the dice, but a deliberate symphony of numbers. We aren't just living in a universe, we are living in a universe that is exactly right. The question remains, is this the ultimate stroke of luck or the signature of a master architect? Part 3. The Multiverse and the Loop of Logic. While the precision of our universe suggests a grand design, many scientists offer a different, more chaotic explanation. We are simply the winners of a cosmic lottery. This brings us to the multiverse theory, the ultimate counterargument to intelligent design. Chapter 1. The Cosmic Lottery. Why we are here. According to the theory of eternal inflation, our universe might be just one bubble in a vast, ever-expanding ocean of other universes. In this scenario, there isn't just one set of physical constants. There are billions. In one universe, gravity might be too strong, crushing everything into black holes instantly. In another, the nuclear force might be too weak, leaving nothing but a cold mist of subatomic particles. We happen to live in the Goldilocks universe because it is the only one where we could exist to observe it. This is known as the anthropic principle. As physicist Max Tegmark suggests, if there are infinite universes with infinite variations, even the most improbable outcome, a universe perfectly tuned for life, becomes an absolute mathematical certainty. We aren't special. We are just lucky. Chapter 2. The Infinite Regress. Who designed the designer? However, the design argument faces a devastating logical paradox, often cited by thinkers like Richard Dawkins in The God Delusion. If our universe is so complex that it requires a designer, then that designer must be even more complex to have created it. This leads to a logic loop, or infinite regress. If complexity requires a creator, who created the creator? If the creator doesn't need a cause, why does the universe? Chapter 3. The Simulation Paradox. Modern science adds a digital twist to this loop. High-profile figures like Elon Musk and philosopher Nick Bostrom have popularized the simulation hypothesis. If a civilization becomes advanced enough to simulate a universe, they would likely run thousands of them. This creates a new paradox. Are we living in base reality, or are we just code in a machine designed by a higher intelligence? And if so, is that programmer also being simulated by someone else? As we dive deeper into this rabbit hole, the line between science, philosophy, and science fiction begins to blur. We are left caught between two staggering possibilities. Either we are a 1 in a trillion miracle, or we are part of an infinite chain of realities where the beginning is just a loop that never truly ends. Part 4. The boundaries of time and general relativity. For centuries, humanity viewed time as an absolute, a steady, unwavering river flowing from the past into the future. But in the early 20th century, Albert Einstein shattered this illusion with his theory of general relativity. He revealed that space and time are not separate stages where events happen. Instead, they are woven together into a single, flexible fabric called space-time. Chapter 1. The Elasticity of Reality. Einstein proved that space-time is not rigid. It can be warped, stretched, and compressed by mass and energy. This means that time is relative. A clock on a mountain ticks slightly faster than a clock at sea level because the Earth's gravity is weaker further from the center. This isn't just a theory. It's a reality that engineers must account for today to keep GPS satellites accurate. Without adjusting for the time dilation predicted by Einstein, your phone's GPS would be off by kilometers within a single day. Chapter 2. The North of the North Pole Paradox. When we apply this logic to the Big Bang, our intuitive understanding of before and after begins to break down. If the Big Bang was the origin of space-time itself, then time did not exist before that moment. The legendary physicist Stephen Hawking famously used a geographical analogy to explain this mind-bending concept. He argued that asking what happened before the Big Bang is as meaningless as asking what is north of the North Pole. Just as there is no north once you reach the top of the globe, there is no time once you trace the universe back to its starting singularity. In this view, the universe is self-contained. It doesn't have a beginning in time because time is part of the universe, not a container for it. Chapter 3. The Imaginary Time. Hawking later introduced the concept of imaginary time in his collaboration with Jim Hartle, the Hartle-Hawking state. They proposed that at the very beginning, time behaved more like a dimension of space. If you go back far enough, the distinction between space and time vanishes. This leads to a startling conclusion. The universe didn't necessarily emerge from a previous state of nothingness. Instead, it exists as a four-dimensional geometry that simply is. As Einstein himself wrote in a letter of condolence to a friend's family, for us physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. By understanding that time is a property of the universe rather than its master, we realize that the Big Bang wasn't just the birth of matter, it was the birth of the very when we live in. Part 5. The Quantum World, the Illusion of Nothingness. In our daily lives, we perceive nothing as a total absence, an empty room, a void, a silence. But as we zoom into the microscopic scale of the universe, we discover that nothing is, in fact, incredibly busy. This is the realm of quantum mechanics, where the very concept of a vacuum is turned upside down. Chapter 1. The Boiling Vacuum. According to quantum field theory, what we call empty space is not empty at all. It is a battlefield of energy governed by the Heisenberg uncertainty principle. This principle allows for energy to be borrowed from the vacuum for a fraction of a second, creating virtual particles. These pairs of particles and antiparticles pop into existence, collide, and annihilate each other almost instantly. Physicist Richard Feynman famously described the vacuum as a seething cauldron of activity. This isn't just theoretical. It has been proven by the Casimir effect, where two uncharged metal plates placed incredibly close together in a vacuum are pushed toward each other by the pressure of these ghostly fluctuations. Chapter 2: The Breakdown of Physics. As we trace this quantum chaos back to the moment of the Big Bang, we reach a wall that science cannot yet climb: the Planck epoch. This represents the first 10 to the negative 43rd seconds of the universe's life. At this extreme density and temperature, our two greatest theories, general relativity, the physics of the giant, and quantum mechanics, the physics of the tiny, refuse to work together. At this point zero, the curvature of space-time becomes infinite, and the laws of gravity as we know them cease to exist. As physicist Michio Kaku often points out, the equations of Einstein blow up at the instant of the Big Bang. This marks the absolute frontier of human knowledge, a singularity where math fails and reality as we understand it has not yet begun. Chapter 3: The Limit of Human Understanding. The paradox of the quantum world is that it tells us the universe was born from a state of nothing that was actually everything. We are the products of a cosmic fluctuation in a vacuum that shouldn't have been there in the first place. By exploring this illusion of nothingness, we realize that the universe is not just stranger than we imagine, but perhaps stranger than we can imagine. We are staring into the engine room of reality, only to find that the blueprints are written in a language we have yet to fully decode. Part 6: The Paradox of Life in a Hostile Universe. If the universe is truly fine-tuned for our existence, we are faced with a jarring contradiction. Why does the vast majority of the cosmos seem actively trying to kill us? From the vacuum of space to the lethal radiation of pulsars, the habitable portion of the universe is smaller than a grain of sand in a desert of chaos. Chapter 1: The Great Silence. Where is everybody? The Fermi paradox highlights this tension. Given the billions of years the universe has existed and the trillions of stars available, the galaxy should be teeming with life. Yet, we see a great silence. This suggests that while the laws of physics allow for life, the environment of the universe acts as a series of great filters. As astrophysicist Neil deGrasse Tyson often points out, the universe is constantly trying to reset the clock on life through asteroid impacts, gamma-ray bursts, and supernova explosions. We live on a thin crust of a planet, protected by a fragile atmosphere in a cosmic shooting gallery. Chapter 2: Redefining Life Beyond the Biological. Perhaps our struggle to find life stems from our carbon chauvinism, the assumption that life must look like us. If the universe is a playground for consciousness, why limit it to biological cells? Some visionary scientists have proposed radical hypotheses. Starivore theory, the idea that stars themselves could possess a form of consciousness or complex information processing within their plasma. Nebular intelligence. Astronomer Fred Hoyle in his science fiction novel The Black Cloud, explored the scientifically grounded possibility of vast, intelligent clouds of interstellar gas that process information through electromagnetic signals. Plasma life. Recent lab experiments have shown that dust particles in a plasma state can form helical structures similar to DNA that can replicate and evolve. This suggests that the hostile interiors of stars or nebulae might actually be cradles for a type of life we cannot yet comprehend. Chapter 3. The Rare Earth versus the Mediocrity Principle. This brings us to a pivotal debate in astrobiology. The rare Earth hypothesis suggests that the sequence of events that led to us, a stable moon, a Jupiter-sized vacuum cleaner for asteroids, and a perfect distance from a quiet sun, is so improbable that we might be truly alone. On the other hand, the mediocrity principle suggests that we aren't special. We just haven't looked far enough or in the right language. As we look at the harshness of space, we must wonder, is the universe a desert with one oasis, or is it a vibrant ecosystem where life is simply waiting for us to expand our definition of what it means to be alive? We are a fragile spark in a dark, cold room. But the very fact that the spark exists at all in such a hostile environment is perhaps the greatest evidence of all that the universe has a bias toward complexity. Part 7. The Dominance of Darkness, Dark Matter, and Dark Energy. Everything we have ever seen, touched, or measured, the stars, the planets, the trees, and our own bodies, is made of ordinary baryonic matter. Yet the most humbling discovery of modern cosmology is that this visible world accounts for less than 5% of the entire universe. The remaining 95% is a vast, invisible empire of shadow that dictates the fate of the cosmos. Chapter 1. The Invisible Skeleton, Dark Matter. In the 1970s, astronomer Vera Rubin observed something impossible. The outer edges of galaxies were spinning just as fast as their centers. According to the laws of gravity, they should have flown apart, scattering stars into the void like water off a spinning wheel. This led to the realization that there must be an invisible glue providing extra gravitational pull. We call this dark matter. It makes up roughly 27% of the universe. It does not emit, absorb, or reflect light, making it completely invisible to telescopes. It acts as a cosmic scaffolding, forming a web-like structure that holds galaxies together and allowed the first structures of the universe to grow. Chapter 2. The Great Expander, Dark Energy. While dark matter pulls things together, an even more mysterious force is pushing the universe apart. In 1998, two independent teams of astronomers discovered that the expansion of the universe isn't slowing down, it's accelerating. The culprit is dark energy, which occupies a staggering 68% of the cosmos. Albert Einstein originally proposed a cosmological constant, lambda, to keep the universe static, later calling it his greatest blunder. Today, we realize he may have been right all along, but for the wrong reason. Dark energy acts as a repulsive force, a property of space itself that gets stronger as the universe grows. Physicist Sean Carroll describes it as the energy of empty space, pushing galaxies away from each other at ever-increasing speeds. Chapter 3. The Great Expander, Dark Energy. While dark matter pulls things together, An even more mysterious force is pushing the universe apart. In 1998, two independent teams of astronomers discovered that the expansion of the universe isn't slowing down, it's accelerating. The culprit is dark energy, which occupies a staggering 68% of the cosmos. Albert Einstein originally proposed a cosmological constant, lambda, to keep the universe static, later calling it his greatest blunder. Today, we realize he may have been right all along, but for the wrong reason. Dark energy acts as a repulsive force, a property of space itself that gets stronger as the universe grows. Physicist Sean Carroll describes it as the energy of empty space, pushing galaxies away from each other at ever-increasing speeds.
Part 8. Mathematics and the double-slit experiment. We are faced with a biological mystery. Why does a brain evolved for survival, designed to track prey and find water, possess the ability to decipher the abstract language of the cosmos? This cognitive leap suggests that our connection to reality is far deeper than mere biology, a concept most vividly illustrated by the strangest experiment in the history of science. Physicist Sean Carroll describes it as the energy of empty space, pushing galaxies away from each other at ever-increasing speeds. Chapter 1. The unreasonable effectiveness of the mind. Evolution is a process of utility. It hones our senses to navigate a three-dimensional world. Yet, as physicist Eugene Wigner famously noted, there is an unreasonable effectiveness of mathematics in the natural sciences. Why should the same neural pathways we use to throw a spear also be capable of calculating the curvature of space-time or the probability waves of a subatomic particle? This gap suggests that mathematics is not just a human invention, but the very source code of the universe. And for some reason, our minds have been granted the password.
Chapter 2. The double-slit experiment. Reality under observation. The most haunting evidence that our minds are linked to the fabric of the universe comes from the double-slit experiment. When physicists fire electrons at a barrier with two slits, the electrons behave like waves, creating an interference pattern on the back wall. However, the moment a detector or a conscious observer is placed at the slits to see which one the electron passes through, the electron changes its behavior. It stops acting like a wave and starts acting like a solid particle. It is as if the universe knows it is being watched and collapses its infinite possibilities into a single concrete reality. As Nobel laureate Richard Feynman once said, this experiment contains the only mystery of quantum mechanics. Chapter 3. Is consciousness the foundation? This phenomenon leads to a radical interpretation championed by physicists like John Wheeler, the participatory universe. Wheeler suggested that observers are not just bystanders, we are co-creators. Without an observer to collapse the wave function, the universe might remain a ghost-like haze of mathematical probabilities. This shifts our perspective of the design paradox. Perhaps the universe wasn't just designed for us, but is actively being sustained by us. Our hunting brains might actually be the biological hardware required for the universe to finally achieve its goal, to be seen, to be measured, and to exist. As we peer through the two slits, we aren't just looking at electrons. We are looking at the boundary where the mind meets matter.
It suggests that the most fundamental constant of the universe isn't gravity or light, it's consciousness itself.
Part 9. Many worlds and spooky connections. As we descend deeper into the quantum rabbit hole, we encounter a reality so bizarre that even Albert Einstein struggled to accept it. This chapter explores the shattering of single reality and the invisible threads that bind the universe together across impossible distances.
Chapter 1. Quantum Entanglement. The Spooky Action. One of the most verified yet baffling phenomena in science is quantum entanglement. When two particles become entangled, they share a unified existence. If you measure the spin of one particle here on Earth, its partner, even if it were on the other side of the galaxy, will instantaneously respond by taking the opposite state. Einstein famously dismissed this as spooky action at a distance, spookhafte Fernwirkung, believing it violated the universal speed limit of light. However, decades of experiments, including those that led to the 2022 Nobel Prize in Physics, have proven that this spooky connection is real. It suggests that at a fundamental level, the universe is non-local. Everything was once connected at the Big Bang, and perhaps, in some ghostly way, it still is.
Chapter 2. The Many Worlds Interpretation. No choice left behind. If the double slit experiment showed that observation collapses a wave of possibilities into one reality, the many worlds interpretation, proposed by Hugh Everett III in 1957, offers a more radical view. MWI suggests that the wave doesn't collapse at all. Instead, every time a quantum choice is made, the universe splits. In one branch, the electron goes through the left slit. In another branch, it goes through the right. This implies that there are an infinite number of yous living out every possible version of your life. As physicist Sean Carroll argues, this isn't science fiction. It is the most literal and mathematically consistent way to read the equations of quantum mechanics. Chapter 3. The Anthropic Principle. The Ultimate Explanation. With billions of potential universes and many worlds branching out, why do we find ourselves in this specific one? This is where the anthropic principle provides a grounding logic. There are two levels to this principle. The weak anthropic principle. We should not be surprised to see that the universe is fit for life, because if it weren't, we wouldn't be here to see it. It is a selection effect, like a fish being surprised that its world is made of water. The strong anthropic principle suggests that the universe must have those properties which allow life to develop at some stage. Together, these theories paint a picture of a participatory universe. We are not just small observers in a vast room. We are the reason the room has taken this specific shape, whether through the invisible threads of entanglement or the infinite branches of many worlds. Our existence acts as a mirror, allowing the cosmos to finally look at itself and choose a path. As we move forward, we must ask, if every possibility exists, does that make our specific choices meaningless? Or does it make our specific branch of reality the most precious thing we possess? Part 10. The Haunting Symmetry Between the Macro and the Micro. One of the most unsettling yet beautiful realizations in modern science is that the universe may be repeating its patterns across scales of magnitude so vast they defy imagination.
When we compare the largest structures in the cosmos to the smallest networks of the human mind, we find a structural mirror image that suggests the universe is not a collection of random objects, but a unified, self-similar system. Chapter 1: The Cosmic Web versus the Human Brain. In 2020, a remarkable study was conducted by an astrophysicist at the University of Bologna and a neurosurgeon at the University of Verona. They compared the network of neurons in the human brain with the cosmic web, the vast distribution of galaxies that make up the observable universe. The results were staggering. The human brain contains approximately 69 billion neurons, while the observable universe is composed of at least 100 billion galaxies. In both systems, only about 3% of the mass is composed of the actual nodes, neurons, or galaxies. The remaining 70% consists of components that play a passive role: water in the brain and dark energy in the cosmos. The visual similarity is not just a coincidence. The mathematical connectivity, the way the nodes cluster and link, follows nearly identical laws of physics. It is as if the universe is using the same blueprint to build a mind as it does to build a galaxy. Chapter 2: The Fractal Universe: Reality in Repetition. This brings us to the concept of fractals, complex patterns that look the same at any scale of magnification. If you look at a coastline from space, it has a jagged shape. If you look at a single rock on that beach, the shape is repeated. Some theorists, influenced by the work of Benoit Mandelbrot, suggest that the universe itself is a cosmic fractal. This would mean that our solar system might be structured like an atom, and our entire universe might be just a microscopic cell within a much larger organism. Part 11: Is the universe a simulation? As we push the boundaries of physics, we encounter a chilling possibility. Perhaps the fundamental building block of the universe isn't matter or energy, but information. This shift in perspective suggests that the grand designer might not be a mystical deity, but a master programmer. And our reality is the output of an incomprehensibly powerful computer. Chapter 1: The It from Bit Theory. The legendary physicist John Archibald Wheeler revolutionized this field with his concept of it from bit. He proposed that every particle, every field of force, and even space-time itself derives its function and its very existence from binary yes or no questions. In other words, bits of information. In this view, the universe is not a collection of objects, but a processing system. If you zoom in far enough on the fabric of reality, you don't find stuff, you find data. Chapter 2: The Simulation Argument. In 2003, philosopher Nick Bostrom published a seminal paper arguing that at least one of the following is true. Humanity will go extinct before reaching a post-human stage. Post-human civilizations are unlikely to run simulations of their ancestors. We are almost certainly living in a simulation. Bostrom's logic is built on the trajectory of our own technology. 50 years ago, we had Pong, 2 rectangles and a dot. Today, we have photorealistic virtual realities, VR, with millions of players. If technology continues to advance, we will eventually create simulations so perfect they are indistinguishable from reality. Statistically,
there would be millions of such simulations, but only one base reality, making the odds that we are in the original version billions to one.
Chapter 3. The glitches in physics. Proponents of the simulation hypothesis, including Elon Musk, point to the strange laws of our universe as evidence of computational efficiency. The speed of light. Why is there a universal speed limit? In a simulation, this would represent the maximum processing speed of the hardware. Pixelated reality. The Planck length, 1.6 times 10 to the negative 35th meters, represents the smallest possible unit of distance. Below this, space-time ceases to exist. This looks suspiciously like the pixels of a digital grid. Quantum superposition. Like a video game that only renders the room you are currently standing in to save memory, quantum particles only take a definite shape when they are observed or measured. Part 13. The Boltzmann Brain Paradox. As we grapple with the mystery of why the universe started in such an orderly state, we encounter what is perhaps the most unsettling thought experiment in the history of physics: the Boltzmann brain. This paradox suggests that everything you remember, your childhood, the book you read yesterday, even the words you are reading right now, might be a total fabrication of a lonely brain floating in a void. Chapter 1. The Math of Randomness. The paradox is named after the 19th century physicist Ludwig Boltzmann, who struggled to explain why our universe is so organized. In a universe governed by entropy, high-order states are extremely rare. Imagine a box of gas. Statistically, it is possible for all the atoms to accidentally cluster into one corner, but it is infinitely more likely for them to be spread out randomly. Now, apply this to the cosmos. The probability of a massive 14 billion-year-old universe evolving with billions of galaxies and trillions of stars is astronomically low. The probability of a single, functional human brain spontaneously fluctuating into existence out of the vacuum, complete with false memories of a life it never lived, is also low, but mathematically higher than the birth of an entire universe. Chapter 2. Are you a flash in the dark? This is the core of the Boltzmann brain paradox. If our universe is a result of a random thermal fluctuation in an eternal void, then it is far more likely that you are a Boltzmann brain than a biological human on a real planet. In this scenario, the vacuum shimmered for a split second. A brain formed with all the neural connections representing your current thoughts and memories. The moment you finish this sentence, the brain will dissolve back into chaos. As physicist Sean Carroll explains, the Boltzmann brain is a reductio ad absurdum. It's a warning sign that our current cosmological models might be missing something fundamental. If a theory predicts that we are more likely to be floating brains than real observers, that theory is likely broken. Chapter 3. The Crisis of Knowledge. The danger of this paradox is that it destroys the foundation of science itself. If you are a Boltzmann brain, your observations of the stars, your experiments in laboratories, and your trust in the laws of physics are all fake data generated by a random glitch in the void. You cannot trust your brain to tell you the truth about the universe if that brain was created by the very chaos it claims to have escaped. Chapter 4. The Great Rebuttal.
Most cosmologists use this paradox to argue against the idea that the universe is just a random fluctuation in an eternal, static background. Instead, it suggests that the Big Bang was a genuine, unique event that set the stage for a real, physical evolution. The Boltzmann Brain forces us to face a terrifying mirror. It asks us, how do you know you are real? The fact that we find this idea so absurd is in itself a powerful piece of evidence that the universe has a deep underlying structure, one that favors the long, slow climb of evolution over the quick, ghostly flash of a lonely mind in the dark. Part 15: Infinity and Your Cosmic Doppelganger. If the universe is truly infinite, we are forced to confront a conclusion that sounds like pure science fiction. Somewhere out there, in the vast reaches of space, there is another you reading this exact sentence. In an infinite cosmos, the concept of being unique isn't just a sentiment, it becomes a statistical impossibility. Chapter 1: The Mathematics of Infinite Space. Cosmologists often distinguish between the observable universe, a sphere about 93 billion light-years across, and the entire universe, which may be infinite. If the universe is infinite, and matter is distributed somewhat uniformly, then a staggering mathematical rule takes over. In an infinite space, every possible arrangement of matter must repeat an infinite number of times. Physicist Max Tegmark from MIT has calculated that if you travel far enough, roughly 10 to the 10 to the 28 meters, you would eventually find a volume of space that is an identical twin to our own. This is not just a world similar to ours, it is a region of space where every atom, every star, and every person is arranged in the exact same configuration as they are here. Chapter 2: The Finite Combinations of Life. The reason for this cosmic copy-paste is simple. There are only a finite number of ways to arrange particles in a given volume of space. Think of the universe like a deck of cards. While there are trillions of ways to shuffle them, if you shuffle an infinite number of decks, you will eventually find 2 decks with the exact same order. Your body and brain are essentially a complex shuffle of atoms. In an infinite universe, that specific shuffle is guaranteed to happen again. Chapter 3: Levels of Infinity. Tegmark categorizes this as a level 1 multiverse. Unlike the many worlds theory, which involves branching timelines, this doesn't require new physics or hidden dimensions. It only requires that space goes on forever. Somewhere, there is a you who decided not to read this today. Somewhere, there is a you who was a world leader. Somewhere, there is a you who is identical in every way, down to the last scar and memory, living a life that mirrors yours perfectly. Chapter 4: The Fragility of the Self. This realization shatters our traditional sense of identity. We often feel like the protagonists of a unique story, but the infinity paradox suggests we're merely one of infinite versions playing out every possible script. As astronomer Carl Sagan once mused, the scale of the cosmos makes our individual lives seem both insignificant and miraculous at the same time. If there are infinite yous, does that make your choices less meaningful? Or does it mean that your consciousness is a thread woven into an eternal tapestry? We are faced with the ultimate humility, realizing that I is not a single point in space-time, but a recurring melody in the infinite symphony of the cosmos. The universe isn't just big, it's so big that it has run out of new things to be, and so it began to repeat, including you.
Part 15. Conclusion. We are part of the miracle. As we reach the edge of our cosmic journey, we are left with a staggering realization. Whether the universe is a masterpiece of intelligent design, a lucky winner in a multiverse lottery, or a complex digital simulation, the simple fact that we are here and that we possess the consciousness to ask why is the ultimate miracle.
Chapter 1. The Fermi Paradox. The Great Silence. If the universe is so fine-tuned, and life is a natural byproduct of its laws, we must face the haunting question posed by physicist Enrico Fermi. Where is everybody? The Fermi paradox highlights the contradiction between the high probability of extraterrestrial civilizations and the total lack of evidence for them. Is life much harder to start than we think? Do civilizations inevitably destroy themselves once they harness the power of the atom or AI? Or are we simply the first ones to reach the stage of cosmic awareness? This great silence suggests that our existence is even more precious than we imagined. We may be the only flame of consciousness in a vast, dark cathedral.
Chapter 2. The Future. Post-biological evolution. As we look forward, the story of life is far from over. Many futurists, such as Ray Kurzweil, suggest we are approaching a singularity, a point where we will transcend our biological limits. We may soon transition from biological entities to post-biological ones, merging our consciousness with machines. This would allow us to survive the harsh environments of space, travel between stars, and perhaps outlive the very planet that gave us birth. In this sense, we are the larval stage of a cosmic intelligence that is just beginning to wake up.
Chapter 3. A way for the cosmos to know itself. As Carl Sagan famously said, we are a way for the cosmos to know itself. Through our eyes, the universe sees its own beauty. Through our mathematics, it calculates its own laws. And through our wonder, it experiences its own mystery. We are not just small, insignificant specks. We are the sensory organs of the universe. Closing thoughts. If this journey through the paradoxes of the cosmos has sparked your curiosity and expanded your horizons, please support our mission to bring these mysteries to light. Like and share this video to help others join the conversation. Subscribe to Knock-Lick Studio to continue your exploration of the deepest secrets of the universe. Thank you for being part of the miracle. Until next time, keep looking up at the stars and wondering why.